Chapter 2 is all about polynomial and quadratic functions. At the very end of it, we're going to pick up rational functions too. So to start off with, polynomial functions are functions that are something that you're very used to seeing. They're very, very nice. They're easy to work with. They have a lot of properties. You have to remember those properties. But you can always use your calculator to help prompt you to remember what property goes with what type of polynomial function. If we take a look at that definition, a polynomial function f of degree n greater than 0 is given by. Now notice that n is an integer. That's important to note. Is given by this wonderful equation we have across here. And what I'm circling are the exponent values on our variables. And that's what determines if we have a polynomial function. If all of the variables have integer values and we do not have a variable divided by another variable, then generally we have a polynomial function. So here, let's say where I'm writing this polynomial function a to the sub n x to the 7th plus a sub n minus 1 x to the 6th plus another coefficient x to the 5th plus another coefficient x to the 4th plus another coefficient x to the 3rd plus another coefficient x to the 2nd plus another coefficient x to the 1st plus, oh, there's no x. So I've written this polynomial function in what's called descending order, where I put the highest exponent value first and then ordered all of the terms of that polynomial from highest to lowest to where we end up with just a constant at the end. And a constant is something that does not have a variable with it. Or if it does have a variable, the variable is x to the 0 power, which is equal to 1. Now, a leading coefficient is what goes in front of the highest exponent power. And then the constant is what goes at the end of your descending order. So looking at C, you might think -4 is the leading coefficient because it comes first, but it's not. If we look at it on part C, it's not in descending order. To get a leading coefficient, we have to find that highest exponential power. So rewriting it in descending order, we can now see that 13 is the leading coefficient and 7 is the constant. Taking a look at A up here, I wrote this down while I was talking. On A, you notice there wasn't a number that didn't have an x value. Well, I put a +0 there because it does have a constant. The constant just happens to be 0, and we tend not to write that down. So in example 1, we need to see which of these are polynomial functions, and we need to find the degree of the polynomial functions. And it says the coefficients, but I'm just going to find the leading coefficient and the constants. Now, in definition 1, it told us what the degree was. It said degree n greater than or equal to 0. In practical matters, the degree is the highest exponential value that we have. So on part A, that's a second degree polynomial. On part B, that's a first degree polynomial. Take a look at part C. Highest exponent value is a 3, so it's a third degree polynomial. Now over here on D, it's in descending order. The highest exponential value is 6, so it is a 6th degree polynomial. Now, looking at the coefficients, 7 is the leading coefficient, 11 is the coefficient of that term, -3 is the leading coefficient, 5 is a constant, -4 is a coefficient of the x squared, -5 is the coefficient of x, 13 is the leading coefficient, and 7 is a constant. So just going through part D, all of those numbers in front of those x values, those are the coefficients that we're looking for. So now we need to answer the question, which of the following functions are polynomials? Well, all of these functions are polynomials. They all have exponential values that are integers. All of the exponents are integers, I should say. And we're not dividing a variable by another variable. So taking a look at E, it's written in descending order. Highest power comes first. So we have a degree of 12. The leading coefficient is 7. The constant is at the end of this function, and it's -1. Coefficients are the numbers in front of the variables. And once again, you can see it's in descending order because the exponent values decrease. Let's look at the rest of this example now. I'm going to go ahead and tell you the next 4 are not polynomial functions. And I'm going to write the reasons why as we go through. On F is not a polynomial because the square root of the leading term, the highest exponent, it's not going to work out to an integer. The square root of 3 does not work out to an integer. There's actually another reason for it, but that's what we're going to go with right now. Both of those reasons work. We're going to focus on the square root of an exponent. It's just not going to work. On G, it's not a polynomial because we have an integer that's negative. Notice up there on that definition, n is greater than or equal to 0, so we have to have non-negative exponents. So we cannot have an exponent less than 0. Right there, that's where that definition has it. Taking a look at H, I bet you've spotted it already. It's not a polynomial. Looking at those exponents, we have a fraction, 2/3. 2/3 is not an integer. And I should be saying actually a non-negative integer. We cannot have negative integers as our exponents either. But we can't have fractions because that's not an integer at all. And I is not a polynomial because we are dividing one variable by another. Now the top and the bottom are both polynomials, but when we divide them, the whole thing becomes something called a rational function, and that is not a polynomial. So looking at these examples and what we've been working with, notice that if you add two polynomials, or if you subtract them or multiply them, you get a polynomial from them. But if you divide two polynomials, it's usually not going to work out. All right, so on example 2 and example 3, we're just going to work with polynomial functions. On example 2, we're to verify the functions a and b are polynomials. So we're just going to do the operations. And in this case, we're going to subtract 3x plus 1, and then we're going to add 13x cubed plus x minus 7 to that first guy in parentheses. So I'm going to write it in descending order. I'm going to take the highest power, put it first, next highest power. I can combine like terms, these values, and I'm going to get a negative 13x and combine like values for the constant, and I have a polynomial function. So adding and subtracting polynomial functions will give you another polynomial function. This one has a degree of 3. Second, let me get everything lined up here. And the leading coefficient is 13 with a constant of -8. We go to B. This one involves multiplication. Notice that square. So when we multiply 2x plus 3, that means we need to multiply the quantity 2x plus 3 twice. So if we're going to multiply this, here we go. We're going to start off, I'm just going to go from left to right. I'm going to take this x and carry it through the second set of parentheses. and then take the -3 and carry it through. And I'm going to just put parentheses around that and write down the third guy. I'm going to get like terms together before I multiply. And now I'm going to multiply these two, but I've kind of run out of room. So I'm just going to have to write it over here as best I can. So 2x squared times 2x is 4x cubed. 2x squared times 3 is 6x squared. And then -3x times 2x is -6x squared. -3x times 3 is -9x. -9 times 2x is -18x. And -9 times 3 is a -27. So combining like terms, I have in descending order 4x cubed. My x squares have canceled. 6x squared minus 6x squared is 0. I'm going to put my x's together and then my constant. So this is a polynomial function. The powers on the exponents, the exponents on the variable, are non-negative integers. It's degree 3, and the leading coefficient is 4, and the constant is a -27. Now I'm going to evaluate. Now we have solved the example 3 before where we evaluate polynomials. So I'm just going to leave that, and in the next video you'll see the answer to those when you plug a -2 into f of x and plug a 3 into f of x. And you can certainly use your calculator and go through and find the answers to those. So we're going to stop the video here and start up on our remarks and example 4 in our next video.